Welcome everyone. In this video lecture, we will solve a GATE 1999 question which is based on the concept of unity gain cutoff frequency in BJT. So the question is, in an NPN transistor with capacitor value 0.3 picofarad has a unity gain cutoff frequency FT of 400 megahertz at a DC bias current IC 1 milliampere. So we have to find the value of C mu in picofarad range and given Vt is 26 millivolts. So the options are 15 picofarad, 30 picofarad, 50 picofarad, and 96 picofarad. So if you know the formula, we can do this question very easily. So first we will solve this question by using the formula. Then after we will go for the theory behind it. So this one is a question for unity gain cutoff frequency of a BJT. So the formula is Ft equals to Gm by 2 pi C pi plus C mu. Okay, or we can write as, we have to find the value of C mu, so we can write as C pi plus C mu equals to Gm by 2 pi into Ft. Ft is given and Gm can be written as IC by Vt into 2 pi into Ft. So now everything is known to us. So we can say the value of IC is around 1 milliampere. So 10 to the power minus 3 I am writing. Okay. Vt 26 millivolt. So 10 to the power minus 3 and 2 into 3.14, or we can write as pi, not issue. And Ft is equals to 400 megahertz. Mega means 10 to the power 6. So this and this should be cancelled out. So C pi plus C mu value is 10 to the power 6. So it should be 10 to the power minus 8 by 54 into 3.14 into 4. Okay, we have already considered the double zero. So 10 to the power 8. So now we have to solve. So I am using the calculator. So 54 into 3.14 into 4. So it will come nearly 10 to the power minus 8 divided by 678.24. So we have to again solve 1 divided by 678.24. So it is somehow 1.47, okay, into 10 to the power minus 3. Okay, this value 1 by this one and into 10 to the power minus 8. So if we solve this one, it will come like what we can say, 1.47 into 10 to the power 8, 9, 10, 11, so minus 11. And if we remove this decimal, so one can write as 14.7 into 10 to the power minus 12. So this should be our 14.7 into 10 to the power minus 12 value. So the value of C pi plus C mu is 14.7 into 10 to the power minus 12, or we can say this one is approximately 15 picofarad. So the value of C pi and C mu value is 15 picofarad. So in this question we have to find the value of C mu, and this one is given C equals to 0.3 picofarad. So if even if we subtract, if we, this one is some confusion, so if we take this C pi is nearly 0.3 picofarad, so it should be 14.7, or better to write 14.7 picofarad. So the C mu value will be 14.7 minus 0.3. So it should be 14.4 picofarad. So we can say the C mu value will be more or less 14.4 picofarad. So now by seeing the answer, we can say this will be the correct answer. That is our 15 picofarad will be the correct answer. Okay, because this one is somehow confusing. So if you consider this as a C pi, still we are getting 4.14.4 picofarad. So it is nearly to nearby. So we can say this should be our 15 picofarad. So this one is the formula we can say. Okay. So this one is the direct numerical. Direct numerical we can solve by using this concept. Okay. This one or using this one, all are the very same thing. And so now next, now we have the answer. Now we have to go for the theory part. Okay, so the theory part. So I have to select the pencil. Now theory behind this. So H, there is a concept of unity gain cutoff frequency. So unity gain cutoff frequency concept comes when the BJT is in the high frequency mode. Okay. So first for that purpose we have to draw the high frequency model. I am just adding high frequency model of BJT. Okay, we have to know the concept of high frequency model of BJT. So then after we can easily say the cutoff frequency calculation, means how to find this FT value. So before that I want to draw the high frequency model. For more detail I will also share one more video link of my video for this high frequency calculation. Okay. So I am saying this one is R naught, this one is our C mu, C pi, okay, and this one is our R pi, and some resistance Rx, and this one say B, some B dash terminal, and this one says collector terminal, and this one is our emitter. For common emitter base configuration we are doing, this one is just C mu, okay, C mu, okay, and just C mu, okay, and this one is our 0.3. Okay, so this one is basically the high frequency model of a BJT where this Rx, so some term, so R pi, C pi, C mu are very well known to us for the high frequency model, and Rx is nothing but simply this one is used to model the resistance of a silicon material. Okay, Rx is nothing but simply to model the resistance of a silicon material of the base region. Okay, and this one is basically the base region between the base terminal, base region between the base terminal and a fixus terminal. So basically there should be some resistance is there. Okay, so that one is the high frequency model, and if we give some signal, say plus of minus vi, okay, so in this one the current is IB. Okay, so what next? So in data sheet, basically in transistor data sheet that I want to write here also. In transistor data sheet, the designer will never give the value of C pi, C mu. Okay, data will be not given, but the designer will provide a curve between HFE versus frequency. This curve will be given in the dataset. HFE versus frequency. From that curve, we can find the value of C pi C mu. Okay. So in the transistor dataset, this HFE versus frequency curve will be given, and this is more or less okay. We will discuss how it is coming, but this one is the curve. This one is somehow a low pass curve. Okay. Okay. This type of curve will be there. This type of low pass curve is there, and minus 3 dB cutoff frequency will be there here. Okay. Okay. So we will discuss where this omega b I am writing this one. We can write this as a HFE, or sometimes we can write as a beta. Okay. In this point we can say the beta value. Okay, so that part will be given. So miss how it is coming we will discuss now. So we have a very good knowledge of this one, this high frequency model. So now after that, we can say the current in this one, the current in the C mu capacitor can be found, because if we are going to draw the HFE versus frequency curve. So we have to make the short circuit the output terminal, because if we know the hybrid model, HFE can be find HFE, the value of HFE, okay, can be find out the I naught by II, okay, or sometimes it is written as IC by IB by keeping V naught equals to 0. So that's why we are short circuited. It is coming from the hybrid model. If we go for the hybrid model, we can know we have to just make it this as a short circuit. Okay, I will also put my H parameter concept of this BJT in the description link. So HFE will be I naught by I, IC by IB, like that. Okay, so we have to sort this thing. So this current will be more or less, if this voltage, I am saying this voltage is a V pi. So this value will be V pi, and for a common emitter, if we make it ground, so this will be at a zero potential, and this should be at a V pi potential. So the current across the C mu, I am writing here I C mu can be written as V pi minus 0 divided by 1 by S C mu. So V pi S C mu will be the current. So this current will be our V pi S C mu. Simple calculation is there, and this one will be GM V pi as per the hybrid model, GM V pi. So the current which are going from this side, the current in this side will be, if we apply simple Kirchhoff's current law, it should be GM minus SC mu V pi. Okay, just because, okay, I am writing here. One current is like VMS, sorry, V pi SC mu is current is going, and now we are interested in this current, say I current. Okay, and this one is also one current is going, GM V pi. So we can write it I plus V pi SC mu, total incoming current at that point equals to GM V pi. So I will be simply GM minus, okay, GM minus S C mu V pi, this current. Okay. So now the value of V pi, so now the value of V pi can be easily calculated. So how it can be easily calculated? I'm just writing. This one is R pi. This one is more or less C pi is there, and this one is C mu, and this one is the R naught resistance. So don't worry about this one. And this one is connected here, and some current source are there. So this value of V pi, this value of V pi is nothing but simply IB, and all this combination of all these R pi, C pi, C mu. So we can say that the value of V pi can be written as IB, in which R pi parallel with C pi plus C mu, because this one is also in the parallel mode, parallel. So parallel C pi plus C mu, or one can also write this as a, because capacitance is in parallel. Okay, so you can write this thing, but C pi plus, if we do this one C mu, it should be C pi plus C mu, just reverse of the resistance. So this one is the value for the V pi. Okay, it is important, that's why I am calculating this one. Now after that, if we solve this one, this V pi, okay, this V pi can be written as IB by 1 by R pi plus C pi plus C mu into S. Okay, because this one is C pi C mu. Okay, so there should be some S term will be there. So we can easily write this expression, or one can write as this as a R pi parallel with 1 1 upon, if we talk about in terms of impedance, one can write as R pi parallel with this, R pi parallel with this, and then after we can write as 1 by S C pi. Means there will be confusion then, so for that thing I am just solving this one. Okay, so after that we can write as R pi into R pi in bracket S C pi. Okay, I'm taking some more space. So this will can be written as R pi by S C pi plus C mu by R pi into S C pi plus C mu plus 1 divided by the S C pi plus C mu. So this should be cancel out, and if we take R pi common here and R pi common from this one, so it should be 1 by R pi plus S C pi plus C mu. Okay, that I am writing directly here. So this can be written as this one. Okay, so this one is a very important one, but we have to practice, and for more detail you can follow the microelectronics books, etc. and Smith. Okay, this one. Okay, so this one is how to solve this one. So now V pi equals to IB by 1 by R pi, S will be in common, C pi plus C mu. Okay, now after that, as we know, HFE value, HFE value will be IC and IB. IC, or as we know, beta equals to IC by IB. IC equals to beta times of IB, or we know IC equals to beta times of IB. So this one is nothing but simply HFE, current gain. Okay, IC by IB. So now we know the value of IC here. IC, the current that is going, where we have find the IC. Okay, wait. Okay, GM minus This one is the total current going. So this one we can say this as a IC. Okay. This one we say this one. This is a IC. GM minus SC mu into V pi, and below that IB value is there. We can write it by multiplying from IB value will become from this expression V pi into 1 by R pi plus C pi plus C mu into S. Okay, so this V pi cancel out. So HFE value will be nearly Gm by 1 by R pi S C pi plus C mu. A more detail is also given in my one more video lecture which is totally dedicated on this concept. You can also follow this one, that will be shared in the description link after finishing this video. So this HFE equals to this one. So HFE GM as a function GM, and we are just eliminating minus SC mu because the GM value will be always much greater than omega C mu. So we are just deleting or just discarding this one. So this one is the expression, we can say this one will be the expression. This one will be the expression for HFE GM by R pi. Okay. So HFE equals to GM by this one, or once again I am writing the same thing. HFE can be written as GM R pi 1 plus S C pi plus C mu into R pi. So this one is somehow more or less a function for a low pass filter. If we this was a current gain HFE, which is nothing but simply our IC by IB is somehow some current gain. So and this one is some factor for this current gain, and one can also write this equation as this one IC by beta, that is our current gain. So if we plot this one, the gain, that is our HFE current gain, we can say this as a current gain. I am also writing current gain, and this should be our frequency. So this one is first order low pass filter function. So it should be like this because this one is a function of 1 by 1 plus s omega, or some k times of this one is a first order first order low pass filter function. So if we plot this one, it go like this. Okay. So in the next part what we can do, this gm r pi we can say this is somehow we can say the value of beta naught. Okay. So this point I am saying is our beta naught. So minus 3 dB cutoff frequency if we have to find, that is our omega b. So omega b 3 dB cutoff frequency can be find by simply by writing s1 by c pi plus c mu into r pi, because in most of the time we have to write as s plus omega. So this will be the cutoff frequency, and another term, if we take this c pi c mu r pi as a common, so this should be the gain portion. So it should be the 3 dB cutoff frequency omega b. Okay. So after this omega b is now there. So now in that one, if we have to find the cutoff frequency, unity gain cutoff frequency, so the gain bandwidth product will be also constant. Gain bandwidth product will be constant. So this should be written as omega naught, or better to write beta naught, sorry, beta naught into omega b. So beta naught will be beta naught into, this should be our omega b. Okay, so 1 by c pi plus c mu into r pi. So beta naught by r pi is more or less some transconductance term. So gm by c pi plus c mu, and omega t can be written as 2 pi ft. So the value of ft can be written as gm by 2 pi c pi plus c mu. So this one is the derivation for that particular concept. Okay, so you can just follow the steps, and this one is the final result that we have observed. So this one for the 3 dB cutoff frequency calculation, so that we have used directly in this numerical. So if you know the formula, you can directly use this concept and you can solve this question. So this is all about this question. Ft equals to gm by 2 pi c pi plus c mu is the unity gain cutoff frequency formula. So this is all about this question. So thank you for watching this video.